Oh, g'day champions, fancy seeing you here. So, we're back with this Nyx, the Achilles Champ wannabe, and I'll run you through the issues with it. First off, very scratchy on the volume pot, and that volume's maxed out and it's barely breaking up, and it sounds very dark. There's a big pop when you switch between the low and the high input, and there's a pop when you switch onto the drive. That's a design fault. I think the high-low switch is a failure, but the pop on the drive is by design, intentionally or otherwise. So let's unplug it and we'll have a bit of a poke around. Alright champions, so I've got her idling, drawing 30 watts from the wall. Just have a look. I've got a little RCA plug installed into the input there. We'll just so measuring 0.1 of a volt. So the main issue with this thing is checking the across the first plate load resistor. You got 273 volts, and across the second one you got 103 volts difference. So it seems to me like we've got an open plate load resistor. Let's power it off and we'll just measure the resistance of it. So that V1A plate load resistor is reading about 5 meg. Fantastic. And the second one is reading about 114k. So that's a bit outside of tolerance too. So we've got some dodgy plate load resistors. These look like the carbon composition ones that you get from CE distribution, which are actually 1/4 watt. So I'll power it back up and show you some other weirdness. So this 6v6 is on the way out. Hear a bit of a pop and crackle. It's gone up to 40 watts from the wall. Pop, crackle, 45 watts. So we've got and back down to 30. I'll just show you the cathode current while that's happening. So Achilles piped up and said, in reference to the 1k value on that resistor, that I'll figure it out in the comments. Really, it's just too big a resistor for this configuration of amplifier, but you know, it's not something that is opinion. It's just it's not the right value for this amp. It's as simple as that. At the moment, we've got 24 volts drop across a 1k resistor on the cathode, and the voltage when measured from cathode to plate, it's 320 volts. So we've got 24.26 volts drop across a 1k cathode resistor. I've confirmed that value is accurate, so divide that by 1000 and you've got about 24 milliamps, I guess you could say, draining through the cathode. So that's the plate current in addition to the screen grid current. So let's measure the cathode to plate voltage. 320 volts. So 24.5 milliamps multiplied by 320 volts equals 7.84 watts. So that's what its idle dissipation is, and that's, bear in mind, including screen current, so that's on the conservative side. You divide that by the 12 watts, the 100% maximum dissipation of a 6v6 GT, and we're running at 65%. Running a single-ended Class A amplifier at 65%, and apparently I'll figure it out, was their comment. Well, I have figured it out, and it's fucking stupid. So anyway, I've got no proof that they put a 1k in there, but in that comment it seems to be that 1k was the factory value. Anyway, moving on. So looking at the voltage on the cathode, when we tap the valve, we get that little blast of current that was happening before. Bearing in mind this is in a combo right next to the speaker. 26 going up, 28, 30, 32 volts, 33 volts. So we've got a bung tube. Oh, I said it, a bung valve. So we'll change that one out. I'll just show you the popping and stuff that's happening with the mic up on the speaker. Drive switch turned off, and every time you turn it on there's a little pop. Not the end of the world, but if they looked at a Blues Junior schematic, they could have seen a way to do this without popping. So looking at a Blues Junior, they've got basically the same principle here. You're introducing a capacitor in the cathode to get some more gain out of it. Here they've gone pretty extreme. They've got the 22 or nothing, just the 1.5k resistor. Because when this FET is turned off, you've got 100k in series with that 22 microfarad cap. That's enough to keep it with ground reference, but not enough to have any serious effect on the audio. When you essentially short this FET out to ground, now that resistor's out of circuit, and it's like you've got a 22 microfarad bypass cap in parallel with this 1.5k bias resistor to ground. So that will boost the gain, boost the bottom end as well, and that's sort of that's the way of switching onto the crunch channel or whatever it is on the Blues Junior. So besides that stuff, we're gonna get rid of this suppression cap. It's not required. Gonna relocate the grounding to the actual chassis and off the transformer mounting points because they always go loose. Gonna upgrade this solid state / valve rectifier switch. Gonna mount it a bit better so it's not sitting on that lip, which is another thing they tried to say they didn't do, but how else could that have come to be? You've mounted a switch on a lip. I'm pretty sure you guys drilled the hole, but I'm also going to sort this out because that's pretty shit, unacceptable. The melted wiring and stuff will sort out. This dodgy fly in the air stuff will sort out. They tried to say that was modified too, but like, how else did you implement this boost thing without it? Because I don't know. How can you say, oh, someone put that in, but it's on the silk screen. It's on the front panel. So there's no extra eyelets here. Anyway, there's this weird sort of sputtering on everything. I think they've cleaned the flux off most of the terminals. It's got that milky look, like half cleaned off flux, and the toothbrush or whatever's just sprayed a bit of stuff on the board, so I'll clean that up as well. This cap here is ridiculously oversized. There's no need for it to be that big because it's hugging that resistor that's emitting quite a bit of heat, so that's shortening the life of that cap. I went over all of this in the previous video, but I'm just giving you a recap. If you want the more thorough go back and check out the video, which I've linked in the description below. Now also remember, champions, remember the voltage we're measuring across this cathode bypass cap for the 6v6? It was like 24.5 volts. That's a 25 volt cap. So putting a 1k resistor there has now taken that cap beyond its tolerance. So, but you know, I'll figure it out. This little blue thing here is a Vishay 25 microfarad 63 volt cap. Look at the size of it. So I've got no idea why I'd use this thing. So we'll throw that in the trash where it belongs. Even though it is an F&T, like good quality, but it's just such a silly form factor. We'll get this all the way over here, away from that resistor. We'll change that to maybe a 560, maybe, is about where I found the sweet spot without smashing the valve too hard. You could go the full 470, but you could be going through 6v6s a bit quicker than necessary. Sitting at about 13-14 watts, I've found a 560 to be about right with most transformers that I use anyway. So we'll probably start with a 560 ohm and then we'll season to taste. Now all of this is made a little bit more difficult because everything's wrapped around the turret like several times, so we'll have to carefully get in there and try not to put too much heat in the stuff, but wick that solder off as quickly as we can. So essentially what we want with the mains, we want to go active to the fuse tip, we want to go from the fuse ring to the switch, we want to go from the switch to the transformer, and the neutral side of the transformer just always be connected to neutral. And another little trick we might do, instead of just the grounded center tap on the heater, we might throw some balance resistors from each of the heater terminals to the cathode right there on the valve socket. So that will give us heater balancing as well as some free elevation from the cathode there. Nice and quick little mod to do to lower the noise floor. And in addition to all that stuff, we'll put some copper foil shielding on the back there just to help out with noise as well. And that will press against the chassis when it's installed and offer another shielded face on the back. So I'm going to get stuck in and do all that. There'll be no sound samples on this one because I'll be doing the comparison with the Tweedtone 5 or Tweedtone V, whatever it's called. So you'll get to hear what it sounds like when it's healthy in that video.